When we're looking at 1A through C, when we're looking at those, first it says to find the center of dilation. So you connect the vertices. You connect J to A with a straight edge. It doesn't have to be a ruler. Connect K to B, connect M to D, connect C to L. And you're going to get the centers of dilation. If the center of dilation is not 0, 0, so which of them had a center of dilation of 0, 0?
C.
Okay. So C, you could use the sides or you could use the vertices to find the scale factor. For example, I could use, so I could just use the 6 and the 2. And I could do second over first, 2 over 6, and it becomes 1/3. Now I cannot do that for A or B because the center of dilation is not 0, 0. So for A, for example, to find the scale factor, second over first, here's my second, here's my first, I have to count a side. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 12. Okay, so this is 6, this is 12. I'm putting second over first so that it shrunk, so my scale factor is 1/2. B is a little bit trickier because there is no side I'm allowed to count. So what did y'all do on B? I love that idea. Use the diagonal. Use MK and compare it to DB. I think that's a great idea. It's way better than trying to use the slope. I love it. So from M to K, it looks like K is at 12, right? So from M to K, it's 12. What about from D to B? So we're going from 6 to 14. So are y'all getting 8? And it is second over first. This time it's growing second over first. And reduce it. What does that reduce to? Okay. So we're good for number 1. What's next?
So Ms. Tainton, you can use like any straight, like you can use J to L and A to C also?
Okay. Page 1. What else on page 1? Oh, y'all said one of these. A 2A?
Mm-hmm.
2A, I don't remember teaching rotating around a point that wasn't the origin. I'm not sure we covered that this year because of Harvey. But either way, you are allowed to use tracing paper at all times. You're allowed to use patty paper. So what you could do is you could set a piece of patty paper on top of this. Although they're not going to ask you something that wasn't covered because of Harvey. It might have just gotten left on the review on accident. But you can take these 2 points and trace them. And then make C your center of dilation. And you can take that piece of patty paper and rotate it 90 degrees to where that plus sign becomes a plus sign on top of itself. Do you know what I mean? So you can take it, keep it at C, and rotate it. And you'll find where A lands and you'll find where B lands. And then you just reflect it over the x-axis.
How would we do it if we didn't have patty paper?
You're allowed to use patty paper. We didn't teach rotating about a point that wasn't 0, 0. Okay, we're looking at number 5 on page 2. We need to find the length of A and the length of B. We know that we've got an isosceles triangle and its altitude has been drawn, but we do not know, we can't use Pythagorean theorem because we don't have 2 sides. So when you can't use Pythagorean theorem, but it is still a right triangle, what do you use? Trigonometry. Yes. Let's find A first. So we're looking for A right here. Here's our angle. That's our reference angle. That's where we're point of perspective. That's where we're standing. So we've got opposite and hypotenuse. Opposite and hypotenuse. Remember, use your formula chart for trig if you forgot them, okay? So it's sine. You always put the angle in parentheses. Equals opposite over hypotenuse, Where's the variable? Where's the variable? Denominator divide. So the first thing we want to do with trig is make sure our mode is in degree mode. You can see that mine is in degree mode because degree is darker. Denominator divide. So 2 divided by sine 65. And then whatever the answer choice is round to, you can just use that. Oh, I'm in the dark again. Yay! 2.2. Okay, so number 5, if we were going to look at part B real quick, or to find letter B rather, we can either take our answer that we got for A and use Pythagorean theorem and double it, or we can do trig again. What function would this be, guys, if we needed to use the 2 and we needed to use the 65? I know a lot of you can't use your mic. Tan 65 equals opposite over, I'm not going to call it B because it's not going to be B. What is it going to be? I used a lot of B's in that sentence. Half of B. Yes. Okay. So 2 divided by tan 65, and then you double your answer. Okay, we're looking at number 20. ABCD is a kite. We know a lot of properties about kites. We know that one diagonal bisects the other. We also know that like a rhombus, the diagonals are, what is like a rhombus? Yeah. So here's a Pythagorean triple, 6, 8, 10. Those are congruent. They already gave us the tick marks. They didn't even have to give us the tick marks. That was nice of them. What about 17 squared minus 8 squared? What do we get? It's another triple. Do y'all know it? 15. Yes. All right, so what's AB? Well, it's 10 because a kite has 2 pairs of consecutive congruent sides. What's AC? Well, it's 16. We got that using Pythagorean theorem. AE is 8. It's already on our picture. ED, Pythagorean theorem, 15. EC is also 8. It matches AE. And BD, 6 plus 15, 21. Okay, that leads us to number 21. Okay, having too much fun with this. If a regular polygon has an, what does this mean? An interior angle? 1. Okay. Now, to find an interior angle of a polygon, unfortunately, this is not on your formula chart. It's n minus 2 times 180. I overlapped my 1, divided by n. I taught you that it is not fun to solve this equation, and I told you not to do it. Instead, I said, isn't there an easier question, or equation rather, using this guy's next door neighbor? Take this guy, 135. Take its next door neighbor, which would be what?
Exterior angle.
The exterior angle. How much would that be?
45.
And instead use the way nicer exterior angle formula, which was in the exterior of a polygon, degrees are always 360. Always, for all polygons. So 360 over n will get you 1 exterior angle. So really I'm doing 360 divided by 45, and it's an octagon. It's an octagon. Now, what's great about the TEKS test is that it is multiple choice. So even if you forgot some of these things, you can take your answer choices. Let's say you forgot this trick. I don't know this trick. I don't know it at all. Take answer choice A, plug it in here, and see if you get 135. Answer choice B. You know what I mean? Use those to your advantage for sure. It's not fill in the blank. Mid-segment does show up a couple of times on your review, so maybe they're going to cover that on the TEKS test. Maybe we need to make sure we remember what a mid-segment is. So a mid-segment is a segment that connects a midpoint to a midpoint. So I know that this matches this, this matches this. Even though it's not isosceles, they don't match each other. But x is a midpoint and y is a midpoint. So what are the coordinates of x, y? How would we do that? Take A, take D, and find the midpoint. Is there a formula on your formula chart for that?
No.
Yeah, there's a midpoint formula. Yeah. You add the x's and divide by 2. Negative 12 plus negative 17. Negative 29 divided by 2. Oh, don't you love when it's a decimal answer? Negative 14.5. And add the y's and divide by 2. 16 divided by 2. 8. So you're finding the average of the x's, the middle of the x's, and the average of the y's, the middle of the y's. And then you do the same thing to these two as well. 4 plus 4 divided by 2. Oh, it's 4. 10 plus 6 again. Okay. So there's the coordinates. What would be the length of xy? How do you find the length of a segment if you know the coordinates? How do you find the length? Length.
The x value.
Okay, you could use the distance formula, but you noticed that this was the same. It was at 8 and 8. So really you're just finding the distance from negative 14.5 to 4, right? You don't need the distance formula because your y is matched. So you just subtract those and you get 18.5. You're just finding the 1D distance straight across because they're both at 8. It's nice and horizontal. Let's look at 28 and 29, determining the equation of the circle from the information. All right. In 28, xy is the diameter. The equation of the circle, you need two things, and it's going to be multiple choice. You don't need to write it from scratch. Let me just give an example because this is not in your formula chart. Let's pretend this is one of the answer choices. I am totally making up numbers. I am not having, this has nothing to do with the problem. We're going to work backwards real quick and then we'll do it. Okay, here's my answer choice A. What's the center of this circle of answer choice A? 2, negative 3. Very good. That's the center. And what's the radius of this circle? Square root of 121. So it's x minus h squared, y minus k squared equals r squared. Okay, so go ahead and take this. This is the diameter. Find the radius. Can you do that? Do Pythagorean theorem. If you want, find how long the whole thing is and then divide it by 2. What do you get for the radius of this equation? Or of this circle? So when we counted those legs, we got 14. This is a 14. And we got 12. Remember, this is going to equal r squared. Well, unfortunately, those are not Pythagorean triples. But when you do 14 squared plus 12 squared, you get 340, and then we square root that. In fact, I would do the 7 and the 6 and just go ahead and dive right into the radius instead of doing the diameter divided by 2, since it's so ugly. So let's do 7 squared plus 6 squared instead. It's 85. 85 is not a perfect square. So I'm not even going to square root it. I don't even need to know r because in the equation it equals r squared. So I'm just going to put 85. 85 is not r. 85 is r squared. So that's what it equals. What about the center? What would you use to find the center of xy? Well, we could just go, you could do midpoint formula, or we could go half the rise and half the run. We could count up 7 and left 6. Where do we land?
2, negative 1.
Cool. So I'm writing my template real quick. So if x is 2, it'd be x minus 2. And if y is negative 1, it'd be y minus negative 1, which is y plus 1. 24. In circle O, the length, okay, that's big. The length of AB is 6 pi. So that's L. Remember, it's that cursive L, not slant height. Find the value of x. So we need to find the angle opening up to it. So we've got a proportion, and it is not in your formula chart. But so kind of you have to memorize it, except it's just part over whole. So L is how long the arc is, but the whole is all the way around the circle, circumference. Equals, good, M, the angle, over 360. Good. So it's the part over the whole distance-wise, and then it's the part over the whole degree-wise, angle-wise. So don't think of it as a scary formula. Think of it as part over whole equals part over whole. So instead of L, I'm going to put 6 pi. What's the circumference of this circle? That's on your formula chart. 2 pi r. 18 pi. There you go. Thanks for annotating. Equals, there we go. What happens to the pi's, guys? That rhymes. Pi's, guys. Yeah.
Cancel out.
Yay. So it's just 6 times 360 divided by 18. Do you like how I'm too lazy to get up and turn those lights back on? Just teach in the dark. 120, 120 degree angle. Anything else from this page? Real quick, 25. We learned, this is not length now. This is the arc measure, which is different than the arc length. We learned that central angles equal their arc, and inscribed angles are half of their arc. So central angles equal their arc, and you got those mixed up. And inscribed angles are half of the arc. So angle CAD is 98 and angle CBD is 49. We are looking at number 41. Okay, triangle ABC is equilateral. So cool, every side is 50. One side of the rectangle is the mid-segment of ABC. Well, which side looks like it's connecting a midpoint to a midpoint? Y'all can kind of tell, right? Yeah, very good. Very good. Now, not only does a mid-segment connect a midpoint to a midpoint, but it's also 1/2 of the length of it, the third side, the side it didn't use. So the length of this mid-segment, we know it. It's half of 50. It's 25. From when we learned mid-segment a long time ago, we learned a theorem that said if this guy down here is a mid-segment, and then let's say this is 42, the length of this mid-segment, let's say this is 57, and this is 18. I don't care. That wouldn't even form a triangle, but whatever. It would, actually. The length of this one is not half of 18. It's not half of 57. It's half of the one it's parallel to. It's 21 long, 21 units long. So a mid-segment is half the length of the third side. Any of these would be 25 because it's an equilateral triangle. So we need to find the area, and they're parallel. Good. Let's find the area of the shaded region. Remember how to find... No, in a trapezoid, a mid-segment is the average of the bases. It's not half because the trapezoid is missing this top. Remember, mid-segment, average of the bases. You add base 1 plus base 2 divided by 2. Okay, good connection, good question. Okay, we're going to do the area of the triangle minus the part we don't want, the area of the rectangle. Okay, the area of the triangle, you can do base times height divided by 2. The base is 50. The height is 25 root 3 divided by 2. Or you can do side squared root 3 over 4. Don't use it if you don't understand that equation, okay? And then you're going to go ahead and get a decimal. Go ahead. You don't have to keep your answers exact tomorrow. Go ahead or Wednesday. Go ahead and get a decimal. And then the area of the rectangle is base times height, 21.65 times 25. So this one's 541.25. And who has the area of the triangle non-exact? Non-exact. Thank you. Oh, root 3? No.
Yeah, I forgot. Sorry.
So 1,082.5. And we can subtract 541.25. Do you get 5? We get like 541 again. That's really awkward. That's weird. 541.3-ish. So on 49, let's answer this first. Was this proportional change? Are these figures similar? No. Because the 6 became 2, that's a scale factor of 1/3. And the 4 became 2, that's a scale factor of 1/2. So no. when it's not proportional, we can't use our little tricks. So we really have to solve it out and find out what happens. Volume of a cylinder is area of the base times the height. So it's pi r squared h versus, we're comparing it to pi r squared h. So let's multiply this through and get all of our like terms together. The pi's cancel. You don't compare something that is the same, so don't worry about that. This y is going to get, there's a y squared and a y squared and a y. So actually, all the y's are going to cancel as well. We only care about the integers. 6 squared is 36 times 4. 2 squared is 4 times 2. So we're comparing 144 to 8. We're comparing it to 8. 144 versus 8. So the volume is, and we can even flip it. I'll just do 144 divided by 8 for now, 18. I'm guessing if we're going from here to here, we might want to say 18 times smaller or less. Since we read from left to right, I'm assuming they want us to do it from left to right. Well, wait, if you put 1 over 18, then stop. It's just 18 times smaller. Don't change it, because you're redundant if you put 1 over 18 and then you say smaller afterward as well.
Wouldn't that actually make it bigger?
Right. It's like they counteract. It's like a negative negative.